Hello dear students, welcome to the physics lecture. So today we are going to discuss one of the concepts from the chapter mechanical properties of solids. See students, in this chapter these are the topics to be covered from this chapter. So the first topic is types of stress and strain. So we are going to discuss different types of stress and strain. And then Hooke's law and stress strain curve, moduli of elasticity and applications of moduli of elasticity such as Young's modulus and applications, bulk modulus and applications, rigidity modulus and applications. And then next is about elastic potential energy. So in this concept we will be studying the energy stored in a wire due to its own weight, and when we stretch the wire, the work required to be done to stretch the wire, and then about the energy stored in a wire. So these type of concepts we will be studying in the elastic potential energy, and at last the basic applications of elastic behavior of materials. So in today's lecture we are going to discuss the first topic, which is types of stress and strain. So my dear students, before entering into the actual topic, let us define basic terms such as the meaning of rigid body, the meaning of deformation force, the meaning of restoring force, elasticity definition, plasticity definition. So these are the basic terms you have to understand before proceeding further. See students, rigid body. So in system of particles chapter you might have studied about the rigid body. Let us have a little recap of this rigid body. So rigid body is any body in which the relative separation between the particles of the body do not change with the external deformation force. Such body is known as rigid body. So by the application of external force on any body, if the distance between the particles, relative distance between any two particles does not change, then such body is said to be rigid body. So there is no perfect rigid body in the universe. So the nearest approach, the closest approach of rigid body is diamond. The closest approach of rigid body is diamond. Right students? Now let us talk about deformation force and restoring force. See students, deformation force is nothing but an external force which changes or tends to change the shape and size of the body is known as deformation force. It's like an external force which changes or tends to change the shape and size of the body. Now, restoring force is nothing but, say when you take any body, any solid body, so I am going to give you the explanation of arrangement of atoms in a solid body. Arrangement of atoms. The arrangement of atoms is like spring-like structure. We can understand with the help of spring-like structure. See here, students, these are the locations of the particles, say atoms, and this separation between neighboring atoms is known as interatomic distance. Now, if the external force is acting on the material body, see, the separation between the atoms will change, whether the separation increases or decreases depending on the type of force applied. So now in general, the atoms are under minimum potential energy state. So when we apply external deformation force, what will happen here is the potential energy of the atoms either increases or decreases depending on the type of force applied. So once the deformation force removed, what will happen here is the atoms or the particles are not with the minimum potential energy. So always the particles are trying to be in their minimum potential energy state. So that is why they tend to, or they try to get the minimum potential energy state. That is why a restoring force developed in them to regain the original shape and size. So we can say restoring force as the internal force developed, the internal force to regain the original shape or size of the body is known as restoring force. Right, students? So before entering into the definition of elasticity, let me ask you one question, that is, which is more elastic? Which is more elastic? Rubber or steel? So try to answer this question by the completion of the lecture, or pause the video and then think about it. Now let's move on to the definition of elasticity. So elasticity is defined as the property of the material, by virtue of which the body opposes the changes in the shape or size of the body when the deformation force is applied and the body regains its shape or size once the deformation force is removed. I repeat, elasticity is the property of the material by virtue of which the body opposes the changes in the shape or size of the body when the deformation force acts on it and regains its shape or size once the deformation force is removed. So with this definition, you can understand very clearly steel is more elastic than rubber, because for the applied deformation force, steel opposes the change in shape or size compared to the rubber. So that we can say steel is more elastic than rubber. So this is the very simple logic to understand which is more elastic, whether steel or rubber. In general, you may feel rubber is more elastic because when you stretch it, so it is easily changing the shape. So but that is not the matter. Elasticity is the property which opposes the change in shape or size when the deformation force acts on it and regains once the deformation force is removed. Right, students? Now, let's move on to different types of stress and strain. So, first of all, stress is defined as the internal restoring force per unit area of cross section. Internal restoring force per unit area of cross section. It can also be written as internal restoring force by area, or you can also write it as external force by area. So this is possible at equilibrium. Here you have to understand one point, that is, when the material is at equilibrium, the internal restoring force magnitude is equals to the external deformation force at equilibrium. Right, students? So here you have to notice one more point, that is, the internal restoring force and external force, that is deformation force, do not form action-reaction pair. They do not form action-reaction pair. Remember this, very important. And next point is here, the SI unit of stress is Newton per meter square. Dimensional formula is ml power minus 1 t power minus 2. Right, students? In case if you are not able to remember the dimensional formula, it is very easy. Here it is a force by area. You can substitute the dimensional formula of force, dimensional formula of area. So after simplification, you will be getting it. And the nature of this stress is, it is actually a tensor quantity. Tensor, it is not a vector quantity. Okay. So in case if it is not there in the options, you can choose a scalar quantity if it is there in the options. Right, students? Now let's move on to different types of stress. So types of stress are actually, we can understand with the help of the force acting on the body. So it is like how the force is acting on the body. So basically we have three different types of stress, out of which the first one is longitudinal stress, the second one is volume stress. It is also known as bulk stress. The third category is shear stress. So it's very simple to understand. Longitudinal stress is nothing but when the force acting on the body is perpendicular to the surface. Force acting on the body is perpendicular to the surface. The stress acting on the body is longitudinal stress. If the equal normal force is acting on the body on every cross section of the body, that's like throughout the volume of the body, equal normal force is acting. So the stress acting on the body is volume stress or bulk stress. Next, shear stress is nothing but when the force acting on the body is tangential to the surface or parallel to the surface. Say for example, if this is a solid body, if the force is acting perpendicular, either pushing force or pulling force, whatever it is. And in this case, equal normal force is acting throughout the area, total volume. And in this case, if the force acting is along the tangent or parallel to the surface, so the stress acting on it is known as shear stress. And see students, here in this longitudinal stress we have two different types to understand. Those are, the first one is tensile stress. Tensile stress is nothing but, see, so first of all, longitudinal stress is nothing but if the force acting is perpendicular to the surface. Now, if the longitudinal stress is due to increase in its length, say this is the original length of the rod, and due to this force, length of the rod increases, so the stress due to increase in length is known as tensile stress. Tensile stress, which is equals to change in which is longitudinal force by unit area of cross section, right students? So that here you can also say it as tangential stress by area of tangential force by area of cross section, whatever it is. Next, second category of stress is compressive stress. See students, the longitudinal stress due to decrease in length is known as compressive stress. Say for example, one end of the rod is fixed to the rigid support and a compressive force acting on the rod. So because of this, there is change in length of delta L, whereas the original length of the rod is L. So in this case, the compressive stress is defined as the compressive force per unit area. So there won't be any change in the definition. So depending on how the force is acting, that particular value. So this is also longitudinal force only. But here the length is decreasing. So the longitudinal stress due to decrease in length is known as compressive stress. Right students? And one simple conceptual point you have to notice here, that is, see, whenever you apply normal force here, so the length is increasing. If the length increases, you can say the stress acting on the body is a tensile stress. Tensile stress is due to the attractive or repulsive forces at atomic level. This is what you have to understand. So when the length increases, what will happen is the restoring force developed in it is like interatomic attractive forces, because the length is increasing, so they attract towards them. And compressive stress is like interatomic repulsive forces. So notice this conceptual point here, right students? Next one is volume stress. So volume stress is simply defined as normal force by area of cross section, or when the solid body is placed inside the liquid, so simply you can say liquid pressure itself, the bulk stress or volume stress. Next, shearing stress. So let us say this is the original location of the solid body. Once the tangential force acts on the solid body, so what we can expect here is there is a shift in the upper end of the body with respect to the lower end. Say if this is x and this is original side length is L. And one more thing here is shearing stress. Shear stress is defined as tangential force per unit area. Simple definition. Right now? So here when the parallel force acts on the surface of the body, what we can expect is there is a shift in the upper surface with respect to the lower fixed one. When shear stress acting on the body, there is change in shape, but there won't be change in size. Right, students? So these are different types of stress. And let us talk about strain. Next concept is strain. See, strain is, in simple words, you can say it is effect of stress. Effect of stress. So, when stress acts on a body, we can expect changes in the dimensions of a body. So, simply we can define strain as change in dimension by original dimension. Change in dimension by original dimension. And strain has no units and dimensions. Right, students? So depending on how the force acts on it, how the shape changes, we have again three different types of strain. Types of strain. Say first one is longitudinal strain. Next one is bulk strain or volume strain. Bulk strain or volume strain. And third category is shear strain. Same logic. Depending on how the force acts on it, we have different types of strain. So first let us talk about longitudinal strain. So longitudinal strain is due to change in length. So simply it is defined as change in length by original length. And one more thing, students, say if it is a rod, the strain developed in it due to increase in length along the direction of force is known as longitudinal strain. Strain developed perpendicular to the direction of applied force is defined as lateral strain. This is lateral strain. This is longitudinal strain. This is longitudinal strain. The strain developed in the direction of applied force, longitudinal. Strain developed perpendicular to the longitudinal force, applied force, that is known as lateral strain. We talk about lateral strain later in this chapter itself. Right, ma? Now, see, if force acts perpendicular to the surface, longitudinal strain. If the force acts, that is equal normal force acts throughout or every cross section of the solid body. Now what change in dimension we can expect here is volume. So this is change in volume, this is original volume. So this change in volume per original volume is defined as volume strain or bulk strain. Right, students? Now shear strain. Shear strain is, see, just now I have drawn one diagram, like if this is the original side length of a body, right? When parallel force acts on the body, tangential force, we can expect change in shape, but there is no change in size, right, students? This angle is known as angle of shear. So angle of shear is equals to the displacement of the upper end of the or upper side of the body divided by original length of the side of the body, x by L. Angle of shear phi is always represented in radians. Phi is always represented in radians. Do remember, here shape changes. There is no change in size. Shape changes. Right, students? Now, one more thing here is, see, this is possible if it is a rigid body. There is no change in size. Right, students? Now, here, let me give you the relation between angle of shear and angle of twist. Angle of shear and angle of twist relation. First of all, you have to understand what is the meaning of a twist. Say, students, we have considered a rod. One end of the rod is fixed to the rigid support. Cylindrical rod. Other end is free. Now, consider this point. This end is fixed. When you apply tangential force at the other free end, say when you apply force likewise, this end is fixed and this end you are applying tangential force. So because of this, we can have twist at this end. So by how much angle it is turning with respect to fixed end is shear angle, and how much angle it is rotating here is angle of twist. So here, when you rotate this, when you apply tangential force here, so when you apply tangential force, this point will shift somewhere here. Now you can write like, it will be shifted here. So this particular angle is known as shear angle, and with respect to the center, so here what you can expect is like this angle, that is known as angle of twist, and phi is angle of shear. Right, students? So when you calculate phi, so you know that angle is equals to arc length. So either you can take this part, see this side, this part, this is the arc length. Angle between these two green dots. Length between these two green dots is arc length by, say, length of the cylindrical rod is L. So L. Now, How you can write theta? Angle is equals to arc length by r, where r is the radius of the cylinder. Right, students? Now you can eliminate L to get the relation. So L is equals to r theta. So phi, angle of twist, is equals to r theta by capital L, where r is radius of cylinder or wire, L is length of the rod or cylinder, and phi and theta I have already mentioned here. Phi is angle of shear, theta is angle of twist. So this is what the relation between angle of twist and angle of shear. So these are different types of stress and strain. So let us discuss few example questions based on these concepts. And before that, let me give you one simple topic under stress, or else we can discuss that under stress strain curve, right? Or else better to discuss here itself. That is the concept of breaking stress. Breaking stress is defined as breaking force per unit area of cross section. Or you can define theoretically it as the maximum stress in which a wire or a material can withstand without breaking is known as breaking stress. And breaking stress depends on nature of material, temperature, impurities added, and it is independent on dimensions of material such as length and area of cross section, and it is also independent on applied force, right? So it is like independent on the force applied as well as area of cross section. It is the characteristic property of particular material. And next, breaking force. See students, breaking force here is equals to breaking stress into area of cross section. So you can say breaking force is directly proportional to area of cross section. So what we can conclude here is breaking stress is constant of proportionality. Breaking force depends on area of cross section, nature of material, temperature, impurities added. You can also define breaking stress as the maximum load required to break the substance, or you can say the maximum load that can withstand a wire without breaking, right? So you can say it is independent on length. Breaking force is independent on length, but it depends on area of cross section. This you have to be careful. So they may give you a question like, for example, a wire of length L can withstand a load of W. Now, if the wire is divided into two equal halves, So they may ask you what is the maximum load that can withstand by individual wires. They can withstand maximum load of W because here length is changed. The maximum load or the breaking force does not depends on length. So it will be same here. So depending on the given situation, you can approach the question. So this is what you have to understand. And here itself, they may ask you to calculate the maximum length of the wire in which the breaking stress acts on a body. So just now I have given that breaking force is equals to breaking stress into area. Breaking stress into area. Suppose if the wire is connected to the ceiling, if this is the load, that is weight mg, so the breaking force is weight of this particular object, that is mg is equals to breaking stress into area. Mass can be written as density into volume. Breaking stress into area. Volume can be written as area into length. Breaking stress into area. Here area term will cancel. The required maximum length that can a body or a material of the wire when it is undergoing or when it is experiencing breaking stress is equals to breaking stress by density into acceleration due to gravity. Right, students? Now let's discuss a few more examples in the calculation of stress and strain. So, for example, if the ratio of radius of the two wires of same material is 2:1, of same material is 2:1. If same force acts, then calculate the stress ratio. So they may say the ratio of radii of two wires of same materials is 2:1, and when they experience the same force, they may ask you to calculate the ratio of stress. First of all, what is the formula of stress? Stress is normal force by area. Here they are saying force is constant. So then stress is inversely proportional to area, that is like pi r square. Stress is inversely proportional to square of the radius. So then S1 by S2 is equals to R2 by R1 whole square, 1 by 2 whole square, 1 by 4. As the radius ratio is 2:1, so here we have R2 by R1, so this is the required